Let's hope this works. Okay. All right, so on the last video, I said we were going to talk about scientific notation. So here we go. This is how to put numbers into and out of scientific notation. So hopefully you remember this from high school math, or honestly elementary school math. But if not, let's get started and see what we can do. So it says, what is scientific notation? Scientific notation is writing numbers as a power of 10. And we will only have one digit, 1, 2, 3, 4, 5, 6, 7, 8, 9, in front of the decimal. When converting into scientific notation, you move the decimal so that you only have 1, 2, 3, 4, 5, 6, 7, 8, or 9 in front of the decimal. You can't have 32 point something in front of a decimal. It would be 3.2 or 3 point something. So if the number is less than 1, where the trouble comes in is the power positive or negative? If the number is less than 1, you're going to move the decimal to the right, and the power is negative. So let's think about that for just a minute. If you have a small number, what do you have power-wise? By the way, this is an interactive class. I don't like teaching bumps on logs, okay? Talk to me. Talk to me. If I have a number less than 1, get off your phone. I want the phone up, all the way up. If I have a number less than 1, what is the power going to be? Negative. The power is going to be negative. So how do you know you have a small number? If you have a what power? Negative power. Small numbers are negative. So less than 1 is going to be a negative power. If you have a number greater than 1, what is your power going to be? Positive. Your power is positive. So you have a greater than 1, you have a positive power. So that's where most people get confused. They know how to move the decimal, but they don't know, is it negative, is it positive? If it's less than 1, it's going to be a what? Negative power. If it's greater than 1, it will be a positive power. Okay, so we're going to take these numbers, put these numbers into or take them out of scientific notation as needed. So this one is a decimal notation number. How do we put it into scientific notation? We're going to move the decimal one place to the what? Right. So then it becomes 3.42 times 10 to the now. Was this number less than 1 or greater than 1? So what is the power going to be? Negative 1. The power is going to be negative 1, and then don't forget your units. Very good. So the power is negative 1, and don't forget the unit. All right, the next one is taking it out of scientific notation. So we see that we have a negative 2. An exponent of negative 2. Automatically in my head I'm saying, is that number greater than 1 or less than 1? If it's a negative exponent, what is it? Greater than 1 or less than 1? It's less than 1. So that means I've got to make this a small number, less than 1. So I'm going to move my decimal to the left, and that means 2 places to the left. What do I put in this hole? A 0. So it becomes 0.0808 grams. 0.080 grams. So it is a small number less than 1. Small number less than 1. All right, on the next one, it is a positive power. That means it's what? Greater than 1. So we're going to move our decimal 1, 2, 3 places to the right. Again, what do we fill in with? What do we fill in with? A 0. So it becomes 2800 grams. Now, I want to stop for just a minute. For those of you that have watched the video, you know about significant digits. And so significant figures should not change when you put a number into or out of scientific notation. Significant figures should not change when you put a number into or out of scientific notation. Here, how many significant digits does this number have? Come on, talk. How many significant digits does this number have? 3. Good. Do we still have 3? Good. How many does this one have? 3. Do we still have 3? We still do have 3, but do you remember in the video when I told you that this 0 in front of non-zero digits is not significant? That's a little confusing. Does this really show 3 significant figures better? It does. And that's why scientific notation is better for that. Because this 0 is not significant, neither is that one. So it still has 3. Now in this problem, by putting it in scientific notation, how many significant digits did it have? It had 3. The way we have written it right now, how many significant digits does it have? Only 2. Are these 2 zeros significant? No, they're not. How do we know they're not? Because there is no decimal at the end. So these are not significant. These 2 zeros are not significant. But should one of those zeros have been significant? According to the scientific notation number, should they have been, one of those, should it have been significant? Yes. So do you remember when I said you have to put some numbers in scientific notation because that's the only way you can show significant digits? Here's an example of that. Can you show 3 significant figures in decimal notation here? No, you cannot. There's no way to show 3 significant digits with decimal notation right here. The only way to do it is in scientific notation. So I'm going to make a note. This has 3 sig figs. This one only has 2 because those are not significant. So that is, we are doing what I've said to, taking it into or out of scientific notation, but really we messed up significant figures by doing that. All right, look at the next one. Is this a big number or a little number? It's little. So we're going to move our decimal 1 place to the right. That's going to be 9 point. Now what about these zeros? Do I add them or not? Yes, because they are after a decimal, which means they are significant. Good. Times 10 to the what? Good job. -1 grams. Why was it -1? Because I moved my decimal 1 place. Is this a small number? Yes, that's why it's negative. Okay? All right. 3,700 with the decimal grams. How many significant figures does this one have? 4. So I'm going to have to move my decimal 1, 2, 3. It's a big number. So that means it's 3.700 times 10 to the what? 3rd grams. Now, both of those 2 problems. Is there any reason to put these 2 problems in scientific notation really? No. Do you end up writing more by putting them in scientific notation than you did in decimal notation? Is it pretty clear that there are 4 significant digits both ways? So the question comes up, how do I know when to put a number in scientific notation? You're going to know to put the number in scientific notation if it makes it easier to write or it clarifies significant figures. That's how you're going to know. That's when you will put it in scientific notation. Okay? All right, on this one, big or small number? Very small. So it's going to be a negative exponent. 1, 2, 3, 4. How do I write it? Come on, talk. How do I write it? Come on. 8.30 times 10 to the, count again, if 1, 2, 3, 4. Negative or positive? -4 grams. Does this show 3 significant digits better? Yes, this shows 3 significant digits much better. Okay? Question on this. All right, you do those 3 right now. You run through those 3 right now. Okay, big number or small number, the first one? Big. So what do we have? Come on, you've all done it. What is it? Times 10 to the what? Seventh. What? Good. You got to put the unit. All right, question on that? All right, 6.85 times 10 to the fourth becomes what? 68, 5, how many? 20, 68,500 grams. How do we know it's a big number? What's it got, guys? Positive exponent. Keep it easy. Don't make this harder than it is. All right, 3.20 times 10 to the negative third, big or small number? All right, so move it over, how many? What's my answer? Point? Very good for putting that 0 on the end. You must have it. Good job. Good job. All right, next topic. Again, elementary school math, rounding. How do you round properly? Proper rounding, many people don't know how to properly round. So let's learn how to properly round. You look at the last significant figure and find the next number to the right. That's all you're doing. You find the one that's the last significant digit, you go one digit to the right. I don't care if there's 10 numbers at the other end, or keep going. Doesn't matter. Last significant digit, look at the next number. If that next number is a 0, 1, 2, 3, 4, then you leave your last significant figure alone and drop your unneeded digits and write your answer. If it is 5 through 9, then you will raise the last significant digit by 1 and drop the unneeded numbers. So let's practice. Round the following to 4 significant digits. Round the following to 4 significant digits. I picked problems that are from atomic mass off the periodic table that people don't round correctly. That's why I'm doing this. So I'm going to leave you alone and let you round these for a minute. Try these. You've been doing this since 5th grade or before, probably 4th grade. All right, I'm going to go ahead and start with you. Hopefully you've gotten these right, then I'll let you finish them just to make sure you've gotten these right. So what is my 4th significant figure here? First 9 or second 9 or the 0? Second 9. Does a 0 make a 9 go up? What's the answer? Very good. All right, again, what is my last significant digit in this problem? The second 9. Why? Because I'm 4 significant digits. 4 significant digits. Does this 2 make the 9 go up? So what's my answer? 74.99. All right, what's my last significant digit? The 5. Does the 3 make a 5 go up? What's my answer? 35.45. Good. Those are all pretty easy, although you'd be surprised at how many people round 22.99 to 23. And that's not correct. So make sure you have these correct answers. Now let's do these. I'm going to let you do the rest of them by yourself. So what's the last significant digit here? 4 significant digits. What's my last significant digit? The second 9. Does a 9 make a 9 go up? Now, what does a 9 become when it's raised by 1? A 10. So it becomes a 10, carry the 1. What does that 9 become? A 10, carry the 1. What does it become? 16.00. 16.00. All right, you do the rest of these right now, and then I'll check you. You do the rest of these. All right, this 9 is my fourth significant digit. Does an 8 make a 9 go up? So what does this become? Say it.
19.
Keep going. 0.00. You must have the 00 to show four significant digits. All right, what is my fourth significant digit here? 5. Tell me what the final answer will be. 192.6. Good. What is my fourth significant digit? The first 6. Tell me what my final answer is. 64.07. Fourth significant digit here. 5. Tell me what my final answer is. 200.6. Good. Fourth significant digit. 6. Tell me what my final answer is. 7.937. Good job. Okay. When we use significant figures in calculations, we must have rules to know how many significant digits are at the end. So what we are doing here is we are taking our significant figure rules that we've learned this whole time, and we are going to apply them in calculations. So grab a calculator. Now today you may use any calculator you have other than a cell phone. You may not use a cell phone. You may use a graphing calculator today, but you may not use a cell phone. After today, no graphing calculators. You need a plain Jane basic calculator. Okay? And I know you all paid a fortune for those calculators. But they have to be used in math class, but we don't allow them in chemistry. So none of your chemistry classes can you use one. Excuse me? I do not. No, I do not. So the two choices on the video from Tuesday, I showed you an older version of the TI 30XA. This is the newer version of the TI 30XA. This is my all-time favorite calculator. I have several old ones of these, and I think it's a very simple, straightforward, inexpensive calculator. You'll use it for everything in the future. Handy, lightweight, not that big old thing that you have. Lasts forever. I would get this one. However, if you are used to a graphing calculator and you like to see a lot of numbers here, this has a 2-line display. Not my favorite, but very simple to use, also acceptable to use. So one of these two calculators is what I would encourage you to get, and you do need to get it by next week if at all possible. You must have it before your first exam. You may not use a graphing calculator on your first exam, okay, period. So if you don't have one, you're out of luck on your exam. All right, today you can use a graphing calculator, but not on the exams. All right, so here's what we want to do. We want to first look at the rules So we have two different rules. The first rule we're going to look at is multiplication division. So the rule for multiplication and division is that the answer must contain the same number of significant figures as in the measurement with the least number of significant figures. So we're looking at total significant figures, and our answer should only have what is in the least, the measurement with the least. Now I've left these, we're going to make the assumption all of these are measured numbers. I'm leaving units off just to save time, okay, and for simplicity today. So how many significant figures does this have? Total significant figures, how many? 3. How many significant figures? How many significant figures? Okay, that means my answer can only have the least, which is how many? 2. So my answer will only be able to have 2. All right, that's the method. I'm going to help you do it but so that we all are doing the same thing at the same time. For right now, grab your calculator and run through all 4 of these and give me answers. Just don't round it. Give me the entire thing that comes on your calculator. All right, hopefully you got those numbers. Anybody not get those numbers? Everybody have these? Okay, make sure you've got these before we start the next step. That's just plain math. Plug it in your calculator, get the answer. That's all we did. But if I ask you on a test, what is the answer to da 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 da? These are not correct answers. Why not? Because they are not rounded to what? Well, proper significant figures. They're not rounded to proper significant figures. So we have to round them to proper significant figures. Good. We've got to round them to proper significant figures. So how many did we say we have to round this one to? 2. So does a 2 make a 2 go up? What's my answer? 82. And I typically box or circle my answer so that I know that's my final answer. All right, go down below this one. How many significant figures do we have here? 5, good. How many do we have here? Good. How many should my final answer have? 3. All right, so this is my third significant digit, the 9. Does an 8 make a 9 go up? To a what? 230. Good. Now what do I have to do to show the reader it has 3 significant digits? Tell me again. Add a decimal. That's exactly right. I must put a decimal to show the reader this is rounded properly. It has 3 significant digits, and this is my final answer. What if I don't put the decimal? How many significant digits does it have then? Only 2. What does the decimal do? The decimal makes the 0 significant. That's what it does. It makes the 0 significant. All right, in this one, how many significant digits does 35.78 have? 4. 22 has 2. My final answer should have 2. Okay, so here are my 2 significant digits. Does a 7 make an 8 go up? Yes, so what's my answer? 790. Now then, do I put a decimal or not? No, I do not. Why not? I do not want this 0 to be significant. If I wanted 3 significant digits, what would I have left it? 787. How many significant digits am I supposed to have, though? Only 2, so I cannot put. So if you didn't watch the video from Tuesday, you don't know this rule. So you're behind. The rule is if there is a decimal at the end of a number, it makes the 0 significant. If there is no decimal, the 0 is not significant. So you'll need to follow back and check that. All right, here we have how many significant digits? 3. Keep going.
2.
Keep going. My final answer should only have 2. All right, so there are my 2 significant digits. Does a 2 make a 0 go up? No. Now, some of you want to say 50 is my answer. I hope nobody says 50 is my answer. Because if I owed you $5,029 and only gave you $50, you are not going to be happy. You would be happier if I gave you what? 5,000. Well, it doesn't seem like it, but significant figure-wise, it is. And that's what you got to remember. We're dealing with significant figures. It doesn't look to you like it's rounded properly. However, we're not rounding it to 4 significant digits. We're only rounding it to 2 significant digits. That means these 2 are my only significant digits. So is 5,000 actually the way we should write it? No. By writing it 5,000, how many significant digits do we have? Only 1. If we put a decimal, that would be 4, but we need how many? How do we have to write this answer? We must write this answer scientific notation. So how do we do that? What's the answer going to be? Come on. 5.0 times 10 to the 3rd. The answer is 5.0 times 10 to the 3rd. We must show 2 significant digits. You put a number in scientific notation. Wake up, guys. You put a number in scientific notation in order to show significant digits if needed. And that's what this does. Does that make sense? Now, I agree with you. You don't like it. I get it. We don't like the fact that it seems like it's not rounded correctly. But you got to get over what you think is correct rounding. Correct rounding is all about how we measured something with the instrument it was measured with. Because significant figures are all about an instrument. So was this instrument, somebody probably didn't use these instruments correctly. Let's think about that for a minute. This one has 2 places after the decimal. This one only had 1, and this one only had 1. Chances are, what should they have all had? 2. Here's my point. How many of you, when you go to measure something, those of you that have ever measured anything, construction management guys, I hope you've measured something, okay? So you've measured something. How many of you are like, oh, it's about 2.5 feet? You ever done that? But that's not proper significant figures. And we in the English world here in the United States, we use a really crazy system of measuring anyway, because we use inches and feet, and we use 1/16 and 1/32 and 3/32 and 5/6 and all this stuff. So then it makes it even more complicated to do scientific notes or do significant figures rather. But we still have to learn how to use them. And so you have to get out of your head, it doesn't look to me like it's rounded properly. Because we are rounding by the proper rules of significant figures. And that's what we have to remember. It's always about significant figures. From this point forward, the beauty of chemistry, as much as you all already are dreading it, some of you, the beauty of chemistry is that what you learn day 1, you will use day 28. That's the beauty of it. The downside of it is if you don't learn it day 1, you're going to be using it and testing on it on the 28th day. And so you got to learn it. That's the beautiful thing, though. It builds upon itself. That's why I like chemistry. It builds upon itself. I don't like learning something that's not useful. If I want to learn something and take the time to learn it, I want it to be useful to me. And it will be. If you all use this, it will be. Funny thing, I just thought of this. A construction management major that I had in, 2005, I think it was 2005, I had a construction management major in class who is now a project manager with some yada yada company. He happened to be at my house out of the blue. He was with somebody else, and he's like, I think I know you. I'm like, okay. I said, did I have you in class? He said, yes, I had you in class. I had you in chemistry class. I can tell you exactly where I sat. He said, I use what you taught me every day. I was like, really? And this guy's like 38 something. I don't know how old he is. I'm like, are you kidding me? He's like, no. Every day you taught me how to do dimensional analysis, and I use it every day. He said, when we're converting pounds of concrete to tons and converting it, the density and figuring out the volume and all that stuff, he said, I use it every day. He said, the other guys are trying to figure out how to do it. He said, I got the answer right there. Here it is. I was like, wow, I got to tell my kids that. I mean, that's cool. That's cool that somebody, so it's useful. That's what I'm trying to tell you. It's useful. Okay, I promise you. I didn't ask him. I did not solicit that advertisement. He just happened to show up and told me that while he's playing ping pong. Okay, so it was kind of cool to find that out. All right, now then, for this part, you do need your calculator. Unfortunately, if you don't have the right one, it's going to be a little harder today, but let's learn how to do your calculator scientific notation. So, even the graphing calculators have this. So let me show you what I'm looking for. On your calculator, you have an EE key or an EXP key. So on this calculator, do you see this EE key down above the 7? Everybody see that? Find the EE key. On the TI-30X2S calculator, it is above the 7, but it is a second function. That's one of the reasons I don't like this calculator as well, because it's a second function. So everyone find on your calculator the EE or the EXP key. Everybody who has a calculator, find that today. Yes? Okay. All right, make a note. EE means times 10. EE means times 10. You do not hit 10. EE means times 10. So you will not hit times 10. You will not hit 10 EE. You will hit EE, and that means times 10. Okay? So how do you plug this in your calculator? How would you plug this in your calculator? And there's a typo right here. I just see it right now. This should be 6. So you plug in 3.48, and then you hit the EE key. On this calculator, you have to hit the second key, the second EE. So 3.48 EE4 times 6.24 EE negative 3. And your negative key is going to be below the 3 on both of these calculators. To switch numbers from positive to negative is on the below the 3. Okay? So let me plug this one in for us. 3.48 EE4 times 6.24 EE3 negative. And you could have done negative 3, it doesn't matter. Equals. And you get 217.152. Everyone get that? All right, let's do it again. I'm going to do it on the other calculator. Pay attention to what I'm doing, okay? We're going to make sure everybody gets this. 3.48 second EE. Now on this calculator, it shows you an E. That means EE. Don't get confused. You hit EE. Don't get confused. You need to do it again. 4 times 6.24 second EE 3 negative. And actually on this one, I believe you do have to put negative 3. You do have to do that. And I'm going to do all that again because on this one, you do have to put the negative first. So 3.48 second EE4 times 6.24 second EE negative 3 equals 217.152. Anybody not get it? Did everybody get it? Did you get it? Everybody get it this time? If you're on a graphing calculator, you gotta do other stuff potentially, but I think everybody should have got it. Everybody get it? If you didn't get it, talk to your neighbors, see if they got it. Okay? All right, you do this one. Do this one now. Now, on this one, do not stop and start. Do 8.4 times 10 to the third times 63.9 divided by, or you could do this divided by that times that. It doesn't matter. It means the same thing. Do not hit equals until the end is my point. Do this one and get the answer. All right, on this one, you should get 1.027685238, yada, yada. It might be a little different at the end there, times 10 to the 10th. Anyone get that? Everybody get that? Okay, good. All right, now, is that my final answer? No. I have to round properly using proper significant digits. So go back to my rule. The rule is you count total significant digits and your answer should have the least. How many do we have here? 3. How many do we have here? 3. My final answer should have how many? 3. So these are my 3. Does that 1 make the 7 go up? What's my final answer? 217. Yes or no? Okay. Now, a question some of you may have, but you're not asking is, do I have to put my answer in scientific notation whenever these were in scientific notation? And the answer is no. Unless I specifically say, write this in scientific notation, you write it however is most convenient for you. And like I said, I typically go with which one requires less work, less ink, less graphite when I'm writing it. This would. That's much shorter to write. So that's how I would write it. Okay? Sometimes you have to write it in scientific notation. It's just a lot easier. So let's look at this one. How many significant digits? 2. How many significant digits? How many significant digits? Good. My final answer should have how many? 2. These are my 2. Does that 2 make the 0 go up? What's my final answer then? 1.0 times 10 to the 10th. Now, do I have to write this answer in scientific notation? I see a head bobbing immediately. Yes, you have to. Why? In order to tell this 0 is significant, that's why. If you just wrote it as 1 with a bunch of zeros after it, does that show you how many significant digits there are? It would only say 1 significant digit would be the 1. Okay? So you must write this in scientific notation. Make sense? All right, y'all are warming up. Thank you. I mean, I know you're warming up because it's hot in here, and I've got a note to ask to turn that down because it's hot to me. But thank you for talking. Keep going. You're doing a good job. All right, addition or subtraction rule. What is the addition or subtraction rule? So addition or subtraction is a totally different rule. And the rule says that the result, that means the answer, must be expressed to the same precision as the least precise measurement. This is usually to the same significant digits, to the same decimal places. I said that wrong. Let me start all over, erase that. The result must be expressed to the same precision as the least precise measurement. This is usually to the same number of decimal places as the least number of decimal places, but not always. And the reason I say not always is because sometimes there is no decimal. Okay? Do you remember the thermometers, the picture of the thermometers? Let me show you the pictures of thermometers in case you've forgotten already. So we had this picture of 3 thermometers. And we were measuring these thermometer temperatures using proper significant digits. Okay? And at the top of the page it says measuring with varying degrees of precision. These, I said, were least precise. This one was more precise. What made this more precise? What made this thermometer more precise? It had more tick marks. So it had more smaller marks. Does that make sense? Look at the measurements we got out of these. Does this have 2 places after the decimal where these each have just 1? So when something is more precise, do we often have more places behind the decimal? That's what I'm trying to point out. So in addition or subtraction, so if I were to add all these numbers together, it says in addition or subtraction, your answer can only be as precise as the least precise. In other words, you can't make this one more precise, can you? No. So when you add these together, how would I have to round if I added all these together? Would I round to the 10th place like these or to the 100th place like this one? I'd have to round to the what? 10th. Why? Because it is the least precise. You cannot make something more precise than it is. So when you add or subtract, you have to go with your least precise. So before we do anything with the rule, let's just do the math. And guys, I'm going to make you work a little bit here. Do not use your calculator. Let's learn how to add and subtract, okay? Do not use your calculator and see if you can add and subtract these. Do this little mental math game for a minute. So everyone can do these with no calculator. Add these together. Add or subtract as needed. I hear calculator. Come on, people. You can do math in your head. Come on. Use our brains here, okay? All right. You should have had these answers, should have gotten these answers. Yes or no? Everybody get these? Okay. All right. Now then. It says the result must be expressed to the same precision as the least precise. So here's what we have to figure out. Which of these is the least precise? Is it 254.0 or is it 36? Which is least precise? 36. So this is least precise. It has no places behind the decimal. It is the least precise. All right? Now, once we know that, we have to say, how is this one rounded? How is this number rounded? Is it rounded to the tens or rounded to the ones or rounded to the tenths? It's rounded to the, tell me, what's this place value? Ones. It's rounded to the ones. It's rounded to the ones. That means my final answer must be rounded to the ones. So what's my final answer? 218. Because this is the ones place, then I have to round to the ones place. You round to the least precise. All right, I'm gonna skip the middle one. I'm gonna skip the middle one for a minute and I'm gonna go to the last one. This one is actually the easier one. Which of these is the least precise? 25.0 is the least precise. And it actually has the fewest decimal points, so that's why I said it's the easiest to figure that out with. It has one place after the decimal. That means it's rounded to the 10th place. So we round this one to the 10th place. Does a 4 make a 6 go up? So what's my final answer? 362.6. 362.6. Yes or no? Okay? All right, this one is harder. Why do you think I say this one is harder? What do we not have? Two things we don't have that make this one a little harder. What do we not have here? There's no decimal. And so you have to know your rules for significant figures. How many significant figures does this have? Only 2. Good job. Only 2. That 0 is not significant. That means it doesn't count for anything other than to hold the place value of hundreds. But it doesn't count. It's not precise. It's not significant. That means this is rounded to the tens. The actual instrument itself was calibrated in hundreds, and you guessed at the tens. Does that make sense? So we say it is precise to the tens. However, this one is precise to the what? Tenths. So this is least precise. This one is least precise. But it's rounded to the tens because the 0 is not significant. That means how do I have to round my final answer? To the what? Tens. I must round this answer to the tens. That means the 5 makes that 1 go to a, what's my answer then? Do I put a decimal? No. No decimal because it's only precise to the tens. Now, most of us are going to be like, that's stupid. That is not a good rounding job on that problem. I agree. It doesn't seem like it's a good rounding job on that problem. I agree with you totally. What happened? What did the person mess up on? What do you think the person probably did incorrectly that measured that number? They did not, what? Use proper? Say it. What are we talking about today? Significant figures. They did not use proper significant figures. Let's make the assumption, this is all hypothetical, I'm just trying to get you to realize how important it is to measure properly. Let's make the assumption that this instrument and this instrument were both the same when they measured these. You with me? Same exact instrument. How was this instrument calibrated? Nope. You guessed at the tenths. It was calibrated in ones. It was calibrated every 1. Let's just pretend this is meters. Let's just pretend that. Let's just pretend it was meters. So that instrument every meter, or we can do feet. Feet's easy because look at the floor. Look at the floor. Everybody got the floor underneath their feet? What is that square tile? 1 foot. It's a 1 square foot tile. Okay? So in this room, I could say this room, the floor in this room is calibrated in every 1 foot. You with me? That makes sense to everybody, right? If this were a measuring instrument, it's calibrated every 1 foot. Every 1 foot. So in this case, our instrument was calibrated every 1 foot. They guessed at 1/10 of a foot. You with me? But they got lazy. They got lazy because they had to count 350. When lo and behold, they just got tired. So they counted 350 feet. The instrument had a mark. The floor had a tile to exactly show you the 350th tile. But they got lazy and just left it 350. Didn't put a decimal. Didn't put a 0.0 because they were lazy. By doing that, what did that make the number look like it had been measured with what kind of instrument? An instrument that had been calibrated in hundreds. You see what happened? It made it look like the instrument had been calibrated in hundreds, which then caused the math to mess up because they added them together and the answer then had to be rounded to 420. And so then when they went to dig the hole that was holding the millions of dollars, they went 420 feet instead of what? 415.3 feet, and they went away empty-handed. Now that's goofy. Has it ever happened before? Yes. There was actually a space flight that somebody messed up on significant figures, and it messed things up because they didn't use their instrument properly. You have to use an instrument properly. We're going to do that a lot. You're going to have on your homework, on your Achieve homework, you're going to see problems where I'm giving you an instrument and you have to read it correctly. Those of you that are construction management and manufacturing engineering technology, guys, you better be paying attention. You've got to learn how to use your instruments properly. Okay? Please learn how to do that. All right, now then, homework just means hopefully you've started your homework. That's just kind of a reminder. Let's flip to day 2. Let's keep going. This is from day 1 notes, day 2 notes. Hopefully you printed those out. So let's keep going. We're still doing significant figures. And we're talking about the combined rule problems. So now we have a scenario where not only do we have addition, subtraction, but we also have multiplication and division within the same problem. So a little bit more difficult. We have to really pay attention to significant figures and precision. We have to think about both things. So if you've had a chemistry class before or some class where it did significant figures, you probably learned the other part. This may be new to you, so let's really focus today. All right, so how many significant digits do we have here? 3. How many do we have here? 3. And this one is also 3, but it doesn't really matter. Why does it not matter? Because what are we immediately doing with this number? Subtracting it. So then what's the rule for subtraction? It is what? Looking at what? If you need to keep those notes out, keep them out. What's the rule for addition, subtraction? Precision, and we go with the least precise. So here we have something that's precise to the hundredths. How we use this is going to depend on what we get here. So how do you do these problems? You do 2 different steps. You have to do both problems. So we're going to take these 2 numbers first and multiply them. And then that's not going to be your final answer, so you cannot just run it all through your calculator and then round at the end. You do that, but you also have to pay attention as you go. So 85.6 times 45.4, and note that answer. 388.6.24. Is that what you get? Anybody else get that? Talk to me.
Yes.
Okay, good. Thank you. All right. That answer, if we were just to stop right there, that answer would have how many significant digits? No. If that were my final answer of this problem, what would I do significant figure-wise? 3. Good job. 3. This should only have 3 significant figures. If I stopped right there, it would only have 3 significant figures, which means those 3 are my only significant figures. Yes? Keep that in mind. Just underline it like I did. Keep that number. You've got it on your calculator. Subtract 6.75 equals. And you get 3879.49. You with me? Okay. Now, this would be the end if I were to stop here. But I'm not stopping here, but I have to now look at the rule for subtraction. And that's looking at least precise. This is precise to the hundredths. This is precise to the what? Say it. Tens. So is this one definitely the least precise? Does that make sense? So how does this answer have to be rounded? To the least precise, which is what? Hundredths or tens? Tens. Tens is least precise. Tens is very imprecise compared to hundredths. So I must round that to the tens. Does this 9 make that 7 go up? What's my answer? Do I put a decimal? No. Good job. Why not? Because if I did, that would mean how many significant digits? 4. And it would also mean that it was precise to the ones. Is it precise to the ones? No, it's precise to the tens. Once again, I know, you're like, I don't like it. I don't like that answer, Miss Brooks. That is not a good answer for that problem. It doesn't matter what you think. It doesn't matter what you like. It doesn't matter what you think. It doesn't matter what you like. The rule is the rule. And the rule says 3 significant digits, that means it's precise to the tens. You have to have this, precise to the least precise. Okay? All right, do this one. 6.74 minus 7.1. And you get negative 0.36. If I were to stop right there for this problem, what would my final answer be? Not 0. Negative 0.4. Negative 0.4. Why? Because that 6 makes the 3 go up. Okay? Does that make sense? Aren't y'all glad you came to the front row? You're doing so well down here on the front row. That's so good. I'm not trying to pick on you. I'm proud of you. You're talking to me. See, you wouldn't have talked back there. Good. All right. So get off your phone back there, buddy. Okay? Off. Put it up completely. All right? Okay, so this would be negative 0.4, which means how many significant digits would that have? If that were negative 0.4, how many significant digits would we have? Only 1. That's terrible, but that's what the rule is, okay? So now take the negative 0.36, leave that on your calculator, times 68.74. And you get negative 24.7464. Yes or no? Make sense? All right. Notice, how many significant digits does this have? You just told me how many? 1. How many does this one have? So my final answer can only have, good job. Do you like it? Nah, you don't like it, but that's what it is. Does that make sense? It can only have 1. I understand you don't like it. It doesn't look like it's proper rounding. Doesn't matter what you like, it matters what you know, and that's the rule. The rule says you've got to follow both precision as well as total number of digits when you're doing these, okay? All right, on this problem, 7.4, this one's going to get a little reprieve here. 7.4 plus 86.7 is 94.1 on the top. Everybody with me? Tell me about the rule for precision. 1 place after the decimal means it's precise to the 10th. 1 place after the decimal means it's precise to the 10th. Is this precise to the 10th? We got lucky. Because both of these are to the same precision, and the answer came out perfectly to the same precision as it will. So we can say it's precise to the tenths, and it has 3 significant digits. We're going to divide that by 16.453, which has how many significant digits? My answer then will have how many? 3. So this one is actually the easier of all we've done. And what do you get? 5.719321704, yes or no? Okay. What's my final answer going to be? Say it again. Good job, because that 9 makes the 1 go up. So 5.72. Yes or no? Make sense? Getting a little easier maybe? Okay. Think how much you've already learned today. Question? Question, you got it? Okay. All right. On this one, what's the rule for division? What's the rule for division here? Total significant figures and go with the least. So this one has how many? 3. This one has 3. All right? So we have to do this part first and get the answer, 92.6 divided by 8.45, and what do you get? Somebody tell me what you get. 10.95 yada yada, and we need to go ahead and 10.95. You don't have to write it all down, but it definitely needs to be on your calculator, and you need to make a note that it's all there. So 10.95857988. If we were to stop right there, what would we round? We would take the 9. That would be our last significant digit. Do you agree? And deal with that, okay? What would it round to? I'm just curious. If we were to stop right there and we needed 3 significant digits, what would you round that one to? 11.0. Very good. 11.0. Good job. Good job. We have the whole thing, though. We need to leave the whole thing on our calculator. Add 16.7 and subtract 88. And tell me what you get. What do you get?
Negative 60.4.
Good. Good job. Good job. Okay. All right. Now then, what's the rule for addition subtraction? We look at the what? Least precise. Least precise. So these had 3 significant digits and was precise to the what? Tenths. So this was tenths. What is this one? Also tenths. What is this one? Ones. My final answer must be rounded to the ones. Does a 3 make a 0 go up? No. How do I write this? Negative 60 point. Very, very good. Why must I put that decimal? Because I must tell the readers the 1 or the 0 rather is significant. It had to be precise to the 1, so the 0 must be significant. And I have to put that. I must put that. Okay? You must put that. All right, the last one is super easy. Does it really follow 2 rules? Nope. Do it then. Do it. See if you know. See if you know that it doesn't follow 2 rules. Run through that. Guys, this clock is correct. So you don't have to keep looking at your phones if you don't wear a watch. This clock up here is correct. Tell me what you get on your calculator. Good job. All right. How many significant figures should we have in our final answer? 2. Why? Because this had, how many did this one have? 3. Keep going. Keep going. And my final answer needs, all right. How do we round it? That 5 makes the 9 change to a 10. Carry the 1 makes it what? I'm getting ahead of myself. It would make it 200, yes? But is that my final answer? If I left it as 200, then what would that be? 1 significant figure. How many should I have? 2. So how must I write this? Very good. 2.0 times 10 to the second. Very good. Very good. Make sense? Very good. Okay. All right. So we've got the basics down for significant figures and doing calculations, rounding, scientific notation, etc. Now, all of this culminates with dimensional analysis. So what is dimensional analysis? Dimensional analysis, also called factor label method. Some of you may have heard of this, called factor label method. Dimensional analysis is a method of solving problems looking at units and canceling units out. Many of you did this in high school. Some of you did not, and that's okay. You can learn it. I am more concerned that you learn the method then you learn how to just give me an answer, okay? One of my things that you'll hear me say is do not give me chicken scratch, okay? Do not give me a little side work on how you just calculated the problem your own way, but you can't really tell me how. You are learning a method. The reason I'm so much a stickler to getting you to learn the method is because if you don't learn the method now, then when we're doing real chemistry, you're going to be lost. So we spend a lot of time learning the method of dimensional analysis. So we're going to learn the method. I'm going to show you the method just real quickly with a problem you already know the answer to, okay? But let me just talk about the gist of it here. It's going to use conversion factors, which is a number that equals another number, a number with a unit that equals another number in a different unit. That's a conversion factor, like 12 inches equals 1 foot, 3 feet equals 1 yard, 5,280 feet equals 1 mile. Those are conversion factors, okay? I talked about this on the first video. Those are conversion factors. Learn the conversion factors. If you don't know your conversion factors, you're going to be lost all semester. You're just hurting yourself if you don't know your conversion factors, okay? Learn your conversion factors. You will use the conversion factor to convert your undesired unit into your desired unit. So we're going to do this problem using dimensional analysis, even though you already know the answer. Get off your phone, okay? If phones are out, guys, I'm going to say this again today. When you look at your crotch, you're looking at your phone unless you've got a serious problem, okay? When you slide away from the table or you're down here doing this, I hope it's looking at your phone. But either way, put your phone up, okay? Somebody is paying for your education. It might be me with my tax dollars, okay? If you have financial aid, it's me helping you pay for your education. Your parents, you probably, some of you are working very hard paying for your education. If you have a phone call or a text message you need to take care of, then quietly get yourself up and take yourself out that door. That will not bother me. What really irritates me, though, is when you try to hide your phones behind the little pop-up things, and you hide them in your lap, and you hide them, and you're looking at, guys, put your cotton picking phone up for an hour and 20 minutes. Put your phone up, okay? Please do that for me, all right? I don't want to have that conversation. I don't want to have to say this again, all right? Anybody who's ever had me in class, I'm the same yesterday, today, and tomorrow on the cell phones, okay? Keep them away. Put them up. All right. Now, give me the answer for this. Some of you already know the answer. What is the answer to this? 60. Okay, we know the answer. That's fine. Now, how would you do this using proper dimensional analysis? I want you to write this down. We start with our given, which is 5 feet. This is the given, okay? That is the given. You need to label, if you've never done this, you need to label given. You need to label that, okay? This is the given. Then you find your conversion factor that helps you. It might just be one, it might be many conversion factors that you need. In this case, it's just one. Do we know a conversion factor that gets us from inches to feet? What is it? 12 inches equals 1 foot. So we put the desired unit on top. What is our desired unit?
Inches.
And what number goes with inches? 12. So we put 12 inches on top, and what goes on bottom is our undesired unit, which is what? Feet, and it goes with 1 foot. Because they are top and bottom, what cancels? The unit of feet. The unit of feet cancels. So now, do we have the desired unit that we wanted, which is inches? And what do we do with numbers on top? We multiply. So what is 5 times 12? 60. Now, that's not it, though. We have to look at significant figures. How many significant figures does this problem have? 2. This had 2 significant figures. So this had 2, and this is exact. Do you remember on your syllabus when I gave you all of these conversion factors and I said memorize these, and then I told you if it is exact, it says do not use significant figures. If it is not exact, then you use significant figures. I went over this on the first lecture. Are these exact? 12 inches in a foot? So we don't worry about significant figures. It's exact. You don't worry about it. You just don't worry about it at all. So this one we don't worry about. So how many should we have in our final answer? 2. How do we write it? 60 decimal inches. And that would be our final answer. 2 significant digits. Now, how many of you saw it in high school or elsewhere? Whoops, I'm so habit-oriented, I can't do it the other way. How many of you saw it something like this? Any of you see it like that? Some of you did. Yeah, some of you saw it like that. Same thing. I just do it this way because it's so much faster and simpler. How many of you have never seen this before? Anybody never seen it before? Okay, and that's fine. Some of you have never seen it before, and that's okay. Stick with me and you'll learn it. Also, there are extra practice videos on YouTube, and there are worksheets that go along with that on the Blackboard site. All right, real quickly before you go, take time. Memorize these before you come back if possible. At least start memorizing these. Please print out your notes before next class period. I think you're going to find it was a little hard to keep up when you have to write it. It especially will be when we start all these problems, okay? So print out the notes. Have a great weekend. Be careful, and I'll see you. If you have a faculty notification letter or you have a question,